The ratio between the de Broglie wavelength associated with the proton accelerated through a potential of 512 volt and that of an alpha particle accelerated through a potential of x volt is found to be 1. Find the value of x. Lambda equals h upon p, where lambda is the de Broglie wavelength of the particle and p is the momentum of the particle. Let us write momentum as m times v. Let us write v in terms of kinetic energy of the particle. So, we get half mv square equals k. From here we find v equals square root of 2k upon m. Substituting the value of v in the above equation, lambda equals h divided by m times v. We get lambda equals h upon m times root of 2k by m. M goes to the square root and cancel with the denominator m. We get lambda equals h upon square root of 2mk. So, we replace the equation lambda equals h upon square root of 2mk, where k is the kinetic energy of the particle. Good. Now, the kinetic energy is the electrical energy q times v, through which the particle is being accelerated. V is the accelerating potential. So, the formula becomes lambda equals h upon square root of 2mqv. From the problem, we understand that few quantity are constant. What are the quantity are constant? Lambda p upon lambda alpha equals square root of 2m alpha q alpha v alpha divided by square root of 2m proton q proton v proton. Fine. From here we start the problem. That will be better. Then the mass of the alpha particle is 4 times mass of the proton and the charge of the alpha particles is 2 times E and the voltage, accelerating voltage for alpha particle is x. That's what we need to find. Then for proton the charge is E and the accelerating potential for the proton is 512 volt. Let us substitute this value in the equation. Before that, in the problem it is given the lambda p upon lambda alpha equals 1. They are equal. So, 1 equal mass of the alpha, charge of the alpha, voltage of alpha divided by mass of the proton, charge of the proton, voltage of the proton. We have taken square on each side, we get this equation. So, let us substitute mass of the alpha as 4 times mass of the proton and charge of the alpha is 2 times E and V alpha is x. We need to find this. So, cancelling the mass of the proton from the numerator and denominator, cancelling the charge E from the numerator and denominator, we get 1 equals 8 times x upon 512. X equals 512 upon 8, so x equals 64 volt.